Namaskar, welcome back. I am Dr. Suresh Thakur, your chemistry teacher. Today we will revise structure of atom, and to revise this chapter we take previous year GSET questions. So what is the benefit of doing these previous year questions? Because that will give you an idea how to go to prepare for the particular exam. Okay, and what type of questions can be asked from this chapter. Okay, so without wasting time, let us focus on the questions. So first question is from GSET 2019. The physical interpretation of psi square is, you know, psi is wave function that represent atomic orbital and means amplitude of the wave function. It may be plus or minus, and that has no physical significance. Psi has no physical significance, but psi square, that represent probability of finding an electron at a particular point in or around the nucleus. So first is, it represents the electron density, but it represents probability actually. So it represents the probability of finding an electron at any given point around the nucleus. That is the physical significance of psi square. Simple. So means for question number 1, D option is correct. Second question. The radial part of an atomic orbital wave function depends on. So you know, psi has two parts, a radial part and angular part. Psi r theta phi has a radial part that depends on the distance and angular part that depends on theta and phi. These are angular part of atomic orbital, and this is a radial part. Actually, radial part of atomic orbital or radial part of atomic orbital wave function depends upon n and l only, and angular part depends on l and m only. So what are the options? L only, n only, n, l and m only. See, no option is exactly true. Now, which one is nearly true? That we will see. See, actually angular part depends upon L and M, and radial part depends upon N and L quantum numbers. Principal quantum number, azimuthal quantum number. It depends upon azimuthal quantum number and subsidiary quantum number. That means here N is unique. In this case, M is unique, right? So that means we can, well, it is not exactly true, but it is nearly true that N, but N only is not the right option. Keep in mind. Though it is asked in GSET 2019, but it should be N and L only. Right? Okay. Yes. This is very easy question from GSET 2018. The scientist who got Nobel Prize in the field of quantum mechanics. Means quantum mechanics is created by, tell me. So keep in mind Heisenberg. He was the creator of evolution of quantum mechanics in 1932. Okay. This quantum mechanics concept was not understood by the public or by the even science fraternity. Then it was reserved for some time. In 1933, he got the Nobel Prize for quantum mechanics, because this mechanics is not easy to understand. Okay, so keep in mind Heisenberg, okay, got the Nobel Prize in the field of quantum mechanics. Okay, so these are questions from GSET 19 and 18. Okay, so next question is the number of radial nodes exhibited by the 4p hydrogenic orbital. So you know, number of radial nodes is equal to n minus l minus 1 and angular nodes equal to l. But here we have to calculate radial nodes only. So what is n for 4p? N is 4, and what is l? P means l is 1, right? So it is 4 minus 1 minus 1 means it comes out to be 2. So number of radial nodes are 2. This is question from GSET 2017. Very easy questions. Next question. The ratio of the de Broglie wavelength of proton to deuterium. So you know, what is the relation between and having same kinetic energies? So you know, lambda equal to h upon square root of 2m into kinetic energy. This is the relation. So ratio of the lambda of proton to lambda of deuterium, that is equal to h upon square root of 2 into mp kinetic energy of p into h and square root of 2 m d into kinetic energy of d, right? H cancel, under root, so lambda p to lambda d proton to deuterium is equal to square root of 2 m d kinetic energy of deuterium divided by 2 m p kinetic energy. So you know, kinetic energy of deuterium is equal to kinetic energy of proton because they have same kinetic energy. That's why it is actually square root of mass of deuterium to mass of proton. So what is the relation between the masses? Mass of proton is 1 unit and deuterium is 2 unit, because 1H1 and 1H2, this is protium and this is deuterium, right? Okay, so this is equal to under root 2. Okay, so that means option C is correct. So these are the questions from GSET 2017. Okay, so these are the questions from GSET 2016. Of the following types of radiations, the only one to be deflected in a magnetic field. So you know, which radiations are deflected? Which are charged. So you know, X-rays, they are electromagnetic radiations, they are not deflected. Gamma rays, again electromagnetic radiations, are not deflected. Neutrons, uncharged particles, have only mass. But beta rays, these are beam of fast moving electrons. So beta rays are deflected by the magnetic field. So simple, right? Now when two electrons interact with each other, the total spin quantum number will be. So you know, if two electrons which interact are in the same orbital, then its total spin quantum number is 0. And if they are in the different orbitals, then they have parallel spin. So their total spin is plus half and plus half. This total spin is equal to plus 1. That means 0 and 1. So both A and B, right? So simple. These are the questions. Very simple questions. Okay, from GSET 2016. Okay, these are the questions from GSET 2014. Question number 8. Which set of quantum numbers is possible for an element? So you know, for given n, L values, maximum value of L is n minus 1. Okay, and m values are from minus L to plus L, right? And S value is plus half or minus half, right? Is it visible? Yes. Okay. So for given n, L values are, because value of n is 1 onwards. Okay. L values are 0 to n minus 1, and m value is from minus L to plus L, and s value is plus half or minus half. Okay. Now come to this, n equal to 1, so L is only 0, but here L is 1. That means this is not possible for an element. Now n equal to 2 and L equal to 1 possible, because if n is 2, L value is 0 or 1. So 1 is given, it's okay. Now if L is 1, so m value is minus 1, 0, plus 1. So 0, it's okay. S is plus half, that's true. Means B option is correct. Rest option n2, L0 is possible, but m should be 0 then. So not possible. N equal to 1, L0 possible, but m should be 0. M1 cannot be possible. Right? Okay. So this is the question number 8. Now 9. Number of planar and radial nodes. So you know planar or angular nodes. Angular nodes or planar nodes. Nodal planes. Okay. That is equal to L. And radial nodes, or they are called as spherical nodes. So that is equal to, that we have done before, minus n minus L minus 1. Right? So now it is 5D. Whatever, x, y, y, z, zx. N value is 5 and L value is 2 for all 5D orbitals. Now L2 means angular nodes or planar angular nodes, or we say nodal planes. So that is equal to 2, that is L, and then it is 5 minus 2 minus 1. So that is again 2. Means spherical nodes or radial nodes is 2, angular node or nodal planes are also 2. Means 2, 2 is the right option. Means C option is correct. Simple. Now line spectra are caused primarily by, so you know line spectra is actually, what is line spectra? Line spectra is emission spectra. What is line spectra? It is actually emission spectra. This is ground state. There is only one ground state, but there are many excited states. So from any excited state, first excited state, second excited state, third excited state, fourth excited state, when electron fall, that release energy corresponding to some frequency, and that is called one line in the spectrum. Okay? So that means that line spectra is caused because of the presence of many excited states, okay, in an atom. So B option is correct. Done. So these are the questions from GSET 2014. Next, these are the questions from GSET 2013. Question is the phenomenon of ejection of electron from the metal surface by action of light. So light means photon and ejection of electron. So that means ejection of photoelectron, and that is called photoelectric effect, that you know all. Compton effect is increase in the wavelength of X-rays or gamma rays when they are strike, when they scattered by some means object. Okay, so that is called Compton effect. What is Zeeman effect? Splitting of spectral lines in the presence of magnetic field, right, in the external magnetic field, and splitting of spectral lines in the external electric field is called Stark effect. Okay, so that is photoelectric effect. Now according to wave theory of radiation, frequency of the radiation is related to wavelength by which relation? So you know that C is equal to lambda into nu. This is the relation between frequency and wavelength. Wavelength means distance for the complete wave, okay, and frequency, that is the time taken to complete this cycle. That means this is per second, this is meter, this is per second, so this is actually speed of light. So that means B option is correct. Last one, number of radial and angular nodes. For this question is repeated many times. Radial and angular nodes, 4D. So for 4D, n equal to 4 and L is equal to 2, because S, P, D, F, L value is 0, 1, 2, 3. Okay, so radial nodes is n minus L minus 1 and angular nodes L. So 4 minus 2 minus 1, that means only 1. And what is L? 2, that is 1 and 2. That is not, there is no such option. It is 4D. Number of radial and angular nodes for 4D. Is it 4D? Wait. Is it? Yes, it is 4D. So for 4D, radial node should be n minus L minus 1. That means 4 minus 2 minus 1. That means it is only 1. And angular nodes 2 means option should be 1 and 2. So no option is right. Okay. So keep in mind it should be 1 and 2. Done? Okay. So this is question number 13. Keep in mind no option is correct. Okay. This is a question again from GSET 13. Which of the following expressions are correct representation of Heisenberg uncertainty principle? So well-known statement is delta x into delta p is greater than or equal to h upon 4 pi, that you know all. Now keep in mind h upon 2 pi is equal to h dash. Okay, so that means it can be written as h over 2. That means this is the right option. Okay, this one is also right. Now come to delta E and delta T. So now you know when this delta x is multiplied by delta T and divided by delta T. Now this is a rate of change of momentum. Rate of change of momentum is energy. So that becomes delta T into delta x. Rate of change of momentum means, see, m delta P equal to m delta V. Delta P over delta T is equal to m delta V over delta T. What is delta V over delta T? A, acceleration. So mass into acceleration is force. So that is delta T into delta x into force greater than or equal to h upon 4 pi. And what is force into displacement? Delta E. So that means delta T into delta E is greater than or equal to h upon 4 pi, or that implies delta T into delta E is greater than or equal to H hash upon 2. So that means first option is also correct. So first, third and fourth. First, third and fourth. Okay, third, fourth and first. That means C option is correct. Got it? So this is about the questions till 2013. So question number 15 is, in the hydrogen spectrum, the Paschen series corresponds to the electronic transition is. So you know, Lyman series is from higher level to 1, Balmer series from higher level to 2, and Paschen series from higher level to 3, means higher level to third level. And for bracket series, it is higher level to 4th, and for P-Fund series, higher level to 5th. So this is the right option. Now, number of radial and angular nodes exhibited by 3D Z square. So you know, for 3D, any 3D, N is 3 and L is 2. So radial nodes are N minus L minus 1. Means 3 minus 2 minus 1 means 0. So radial nodes are 0 and angular nodes are L 2, means A option is correct, right? Got it? Now last one, for the following particles having same kinetic energy, which would have the maximum de Broglie wavelength. You know, lambda equal to H upon square root of 2m into kinetic energy. That means as kinetic energy is same, H is same, 2 is constant, so lambda is inversely proportional to square root of m. That means lower is the value of m, higher is the value of wavelength. So you know, alpha, beta, proton, neutron. So alpha particles are heaviest. What about mass? Alpha particles are heaviest. Then come to neutron. Then come to proton, and last is beta particle. This beta particle means simple electrons. Okay. So that means lambda is maximum for beta particle. Right? Got it? These are the questions from GSET 2010. Questions from GSET 6. Start from 20th. The ionization energy of hydrogen atom is given 13.6 electron volt. So kinetic energy of the electron in hydrogen atom is. So you know, kinetic energy is equal to minus of total energy, and potential energy is equal to 2 times total energy. Okay, and ionization energy is equal to E infinity minus En. That means E infinity, you know, it is 0, so that is equal to minus En. That means ionization energy is equal to kinetic energy. Ionization energy is equal to kinetic energy. That means A option is correct. Right? Now, number of possible values of magnetic quantum number M for F electron. For F electron, you know, L is 3 and values of M are minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. Total 1, 2, 3, 4, 5, 6, 7. So total 7 values are possible. Or you can write it as 2L plus 1. That is 2 into 3 plus 1. Total 7 values are possible. Right? Now, 18th question. So, next question is the wavelength of the second line in the visible series. So, you know, for visible series is Balmer series, N1 is 2, and second line, so first line N2 is 3, and for second line N2 is 4. So, wave number, that is 1 upon lambda, equal to 109,678 into 1 upon N1 square minus 1 upon N2 square per meter. So that implies it is 109,678 into 1 upon 2 square minus 1 upon 4 square, right? So that is 109,678 1 upon 4 minus 1 upon 16. So that is 109,678. 16 is LCM. So it is 4 minus 1. So that is 1 upon lambda equal to 109,678 into 3 over 16. Right? So that implies lambda is equal to 16 over 3 into 109,678 meter. Right? So from here, sorry, it is per centimeter, right? So it is now in centimeter. So that can be written as 16 divided by 3 into 1.09678 into 10 raised to power 5 from here and 2 from here. So minus 7 meter. So then if it is 1600, then it is nanometer. That is for minus 9. So it comes out to be in 3 digits. See, this is not true. This is 4 digits, 2 digits. This is 3 digit. So we need, because it is round about 4 point something. So 2 digit more to make it 10 power minus 9. So it is actually 486 nanometer. Means without solving it we can do. Okay. So these are the questions from GSET. I think 2006. Yes, 2006. So 21st question. Question is the NLM quantum numbers characterizing the 2pz orbital are. So you know, for 2pz n is 2 and for p l is 1. So n is 2, l is 1, n is 2, l is 1, n is 2, l is 1. This is not possible, right? Then it is z actually. So for pz, m is 0. Keep in mind. Otherwise for l equal to 1, m values are minus 1, 0 and plus 1. For pz, it is 0. So A option is correct. Right? Very easy question. Next, which of the following orbitals has finite electron density at the nucleus? You know, S orbital is closest to the nucleus. Then come P, then D, and then F. That means orbitals which has finite electron density at the nucleus is obviously S orbital. A of A, okay. For which of the following atomic orbitals XY is not the nodal plane? So you know, for PZ, XY is the nodal plane. Now for DZ square, so you know, when we draw DZ square, for DZ square it is dumbbell along Z axis and ring of electron density in the XY plane. Ring of electron density in the XY plane. So that means for DZ square, XY is not the nodal plane. Done? Okay. The limit of Lyman series. The limit of Lyman series and limiting line means when you know for Lyman series n1 is 1 and limit of the series is n2 is infinity. So for Balmer series you know 1 upon lambda nu bar, that is equal to 109,677 1 upon n1 square minus 1 upon n2 square per centimeter. That implies it is equal to 109,677 divided by 4 per centimeter. That's it. Easy. So that means B option is correct. Then electromagnetic radiation is deflected in. So you know, electromagnetic radiation is not deflected by electric field or magnetic field, because electromagnetic radiation is associated with electric and magnetic fields which are perpendicular to each other as well as to the direction of propagation. It is like this. Okay, so it is, first option is electric field only, magnetic field only, neither A nor B. So C option is correct. So that's all. These are the questions from GSET 2002. 21st question was from 2004 and 22nd question was from 2003, and these are the questions from 2002. First two from December 2002 and last question from January 2002. So that's all about structure of atom. These are the questions came in previous years. Thank you very much for watching this video. Do like, subscribe and share my channel. God bless you all. Happy learning. Jai Hind, Jai Bharat.